Luna-2, originally named the second Soviet cosmic rocket, and nicknamed Luna-2 in contemporaneous media, was the sixth of the Soviet Union's Luna program spacecraft launched to the Moon, U-1 number 7. It was the first spacecraft to reach the surface of the Moon, and the first human-made object to make contact with another celestial body. The spacecraft was launched on the 12th of September 1959 by the Luna 8K-72S and I-17B rocket that followed a direct path to the Moon, in addition to the radio transmitters, sending telemetry information back to Earth. The spacecraft released a sodium gas cloud so the spacecraft's movement could be visually observed. On the 13th of September 1959, it impacted the Moon's surface east of Mare Imbrium near the craters Aristides, Archimedes, and Autolycus. Prior to impact, two sphere-shaped pennants with USSR and the launch date engraved in Cyrillic were detonated, sending pentagonal shields in all directions. Luna-2 did not detect radiation or magnetic belts around the Moon. Luna-1 and the three spacecraft of Luna program before it were part of the U-1 series of spacecraft with a mass of 156 kilograms 344 pounds. Luna missions that failed to successfully launch or achieve good results remained unnamed and were not publicly acknowledged. The first unnamed probe exploded on launch on the 23rd of September 1958. Two more launches were unsuccessfully attempted on the 11th of October 1958 and the 4th of December 1958. Luna-1 was the fourth launch attempt and the first partial success of the program. It launched on the 2nd of January 1959 and missed the Moon by 5,965 kilometers 3,706 miles. One mission separated Luna-1 and Luna-2. A launch failure that occurred with an unnamed probe on the 18th of June 1959. Luna-2 would be the Soviet Union's sixth attempt to impact the Moon. It was the second of the U-1A series, modified to carry a heavier payload of 156 kilograms 344 pounds, and had a combined mass of 390 kilograms 860 pounds. Luna-2 was similar in design to Luna-1, a spherical space probe with protruding antennas and instrumentation. The instrumentation was also similar to the Luna-1, which included a triaxial fluxgate magnetometer, a piezoelectric detector, a scintillation counter, ion traps and two gas discharge counters. While the Luna-2 included 6 gas discharge counters, there were no propulsion systems on Luna-2. Luna-2 carried 5 different types of instruments to conduct various tests while it was on its way to the Moon. The scintillation counters were used to measure any ionizing radiation, and the Cherenkov radiation detectors to measure electromagnetic radiation caused by charged particles. The primary scientific purpose of the Geiger counter carried on Luna-2 was to determine the electron spectrum of the Van Allen radiation belt. It consisted of 3 STS-5 gas discharge counters mounted on the outside of an airtight container. The last instrument on Luna-2 was a 3-component fluxgate magnetometer. It was similar to that used on Luna-1, but its dynamic range was reduced by a factor of 4 to plus or minus 750 gammas NT so that the quantization uncertainty was plus or minus 12 gammas. The probe's instrumentation was powered by silver zinc and mercury oxide batteries. The spacecraft also carried Soviet pennants, which were located on the probe and on the Luna-2 rocket. The 2 sphere-shaped pennants in the probe had surfaces covered by 72 pentagonal elements, in a pattern similar to that later used by association footballs. In the center was an explosive charge, designed to shatter the sphere, sending the pentagonal shields in all directions. Each pentagonal element was made of titanium alloy. The center regular pentagon had the state emblem of the Soviet Union with the Cyrillic letters USSR engraved below, and was surrounded by 5 non-regular pentagons, which were each engraved with 1959. USSR September 1959. The third pennant was similar engravings on aluminum strips, which were embossed on the last stage of the Luna-2 rocket. The scientists took extra, unspecified precautions in preventing biological contamination of the Moon. A launch was first attempted on the 9th of September 1959, but the first stage engines failed to reach full thrust, and the launch was aborted while the rocket was on the launch pad. The second attempt occurred on the 12th of September 1959, and Luna-2 lifted off at 6 hours 39 minutes and 42 seconds GMT. Once the vehicle reached Earth's escape velocity, The upper stage was detached, allowing the probe to travel on its path to the moon. Luna-2 pirouetted slowly, making a full rotation every 14 minutes, while sending radio signals at 183.6, 19.993 and 39.986 MHz. The probe started transmitting information back to Earth. Using 3 different transmitters, these transmitters provided precise information on its course, allowing scientists to calculate that Luna-2 would hit its mark on the moon around 0:05 on the 14th of September Moscow time, which was announced on Radio Moscow. Because of claims that information received from Luna-1 was fake, the Russian scientists sent a telex to astronomer Bernard Lovell at Jodrell Bank Observatory at the University of Manchester, having received the intended time of impact and the transmission and trajectory details. It was Bernard Lovell who confirmed the mission's success to outside observers. However, the American media were still skeptical of the data until Lovell was able to prove that the radio signal was coming from Luna-2 by showing the Doppler shift from its transmissions. Luna-2 took a direct path to the moon, starting with an initial velocity from Earth of 11.2 kilometers per second, 25,000 miles per hour, and impacting on the moon at about 3.3 kilometers per second, 7,400 miles per hour. It hit the moon about 0 west and 29.1 north of the center of the visible disk at 0 hours 2 minutes and 24 seconds Moscow time on the 14th of September 1959. The probe became the first human-made object to hit another celestial body, to be able to provide a visual from Earth on the 13th of September. The Luna-2 released a vapor cloud that expanded to a 650 kilometers per 100 miles diameter, and was seen by observatories in Alma-Ata, Burakan, Abasjamani, Tbilisi, and Stalinabad. This vapor cloud also acted as an experiment to see how the sodium gas would act in a vacuum and zero gravity. The last stage of the rocket that carried Luna-2 also hit the moon's surface about 30 minutes after Luna-2, but there was uncertainty as to where it landed. Bernard Lovell began tracking the probe about 5 hours before it impacted the moon and also recorded the transmission from the probe, which ends abruptly. He played the recording during a phone call to reporters in New York to finally convince most media observers of the mission's authenticity. The radiation detectors and magnetometer were searching for lunar magnetic and radiation fields similar to the Van Allen radiation belt around Earth, sending information about once every minute, until its last transmission, which came about 55 kilometers 34 miles away from the lunar surface. Although it did prove previous measurements of the Van Allen radiation belts that were taken from Luna-1 around the Earth, it was not able to detect any type of radiation belts around the moon, at or beyond the limits of its magnetometer's sensitivity. Luna-2 showed time variations in the electron flux and energy spectrum in the Van Allen radiation belt, using ion traps on board. The satellite made the first direct measurement of solar wind flux from outside the Earth's magnetosphere. On its approach to the lunar surface, the probe did not detect any notable magnetic field to within 55 kilometers 34 miles from the moon. It also did not detect a radiation belt around the moon, but the 4 ion traps measured an increase in the ion particle flux at an altitude of 8,000 kilometers 5,000 miles, which suggested the presence of an ionosphere. The probe generated scientific data that was printed on 14 kilometers 8.7 miles of teletype, which were analyzed and published in spring 1960. Luna-2 was a success for the Soviets and was the first in a series of missions, lunar impactors that were intentionally crashed on the moon. The later US-made Ranger missions ended in similar impacts. NASA used hard spacecraft impacts to test whether shadowed moon craters contain ice by analyzing the debris that got thrown out. The pennant presented to Eisenhower is kept at the Eisenhower Presidential Library and Museum in Abilene, Kansas. A copy of the spherical pennant is located at the Kansas Cosmosphere in Hutchinson, Kansas. On the 1st of November 1959, the Soviet Union released 2 stamps commemorating the spacecraft. They depict the trajectory of the mission,